Today we're going to be starting strings, and here's some code that we'll put into REPL and we'll check the output, but I want you to write down the output as you go so that you have a list of the methods and what they produce. So we're looking at methods for strings today, and the first thing we're going to do is we're going to make string a word equal to computer. A string is a group of characters. The first character in the group is index 0. So C is index 0, O is index 1, and so on. So there are 8 characters, 0 through 7. Since string is an object, we can create it as an object. We can say string word is equal to new string apple. Now this is not necessary, but we could do this because string is a class and we're making an object. Word and word1 are reference variables that hold the memory location of computer and apple, respectively. There is a memory location for computer, and word is pointing to that memory location. Apple has a memory location, and this object word1 is pointing to that memory location. Strings are immutable. They cannot be changed. What happens is you create a new string. System out print line 5 equal to 5. When we print this, this will print out true. This is a comparison. If you have something like x is equal to 10, that assigns 10 to the variable x. When you have double equals, that is a comparison of the two values. So that'll just be true. String word2 is equal to computer. Well, now we have a place in the memory where the word computer is stored, or the string computer, and we already kind of assigned that. So now word and word2 are pointing to the same memory location. They're pointing to the same place. So if we compare word and word2, it will say true. Now it says true not because both of them say computer, it's because both of them are pointing to the exact same memory location. So when you use double equals, it compares memory location. String word3 equals new string apple. Now these two are different. This apple and this apple are different because we told Java to create 2 new ones. So now if we compare word1 with word3 with the double equals, it will actually say false, because it's not pointing to the same object or to the same memory location. Those two objects are pointing to 2 different ones because we use the word new. Now the dot equals method compares the value of those memory locations. So when we have word1 is apple and word3 is apple, and we're saying now don't compare the memory locations, compare the actual values, this will say true. Word.substring 0 to 3, so we're going back to word, which is computer, and we're going to print out index 0 to 3, but not including 3. So we'll print out the C, the O, and the M, but we will not print out the P, so it'll be COM. Returns from 0 to 3, not including index 3. Now if you do substring with only one number, that does the third character, the third index, all the way to the very end of the word. So this will start at 3 and do the rest, pewter. Returns word3 to the end. System out print line word dot character at. So we want to know what character is at index number 2. So it's not the second letter, it's actually the third letter, but it's at index number 2. So this one will print. This method returns the character, 2, M. And then we have a print statement there, so it'll print out M. Word length. The length of the word is 8 characters long with index 0 to 7, but there are 8 characters. So this will print 8. Returns the number of characters in the string. System out print line word1.length. The return values can be stored in variables. We can put the lengths in variables, but what's word1? Let's go up here. 1, 2, 3, 4, 5 characters long, so this will print out 5. Now that's an integer value, so we can put the lengths of words into an integer variable. So we print out num, word is 8 characters long. So that'll print out 8, and we showed here that we just stored that value in a variable. System.print word character at 0. Word character at 0. Word is computer, so capital C. Capital C. And then plus a space, so we're going to go space. And then word character at index 7. They're making an announcement right now. That's what you hear in the background. Character at 7 on word as well. Character at 7 is R. So C space R. String name equals word.substring 26. So we're going to actually make a new string. We're going to send it, we're going to reallocate names reference to a different reference. So word.substring 2 to 6. 2 to 6. 2, 3, 4, 5. Remember, it does not go to 6. It does not grab the 6th. It goes actually 2 through 5. So MPUT. So we've changed name to MPUT, and that's what it'll print, MPUT. System.out.print word.index of MPU. Index of MPU. MPU starts at 2. So this, the index of this is actually at, it starts at 2. Oh, but we changed it. Oh, wait, we changed it. So it's not 2. Name is now MPUT. So MPU, that actually starts at 0. My bad. Index can search for characters in strings. So index, word index of M is actually 0. Word 1, last index of P on word 1. Word 1, last index of P, 0, 1, and 2. So this will be a 2. Word 1, index of Z. Well, word 1 does not have a Z in it. Where is word 1? Right here. It does not have Z in here, and when that happens, the return value is -1. Print get first chunk, computer at Apple. And I think I have that. So let's check the outputs anyway. Let's go to the, that's not it. That's it right there. There's all the values that we talked about. And here is the method. I'm going to try to get this to work. So maybe you should just kind of write this line that I'm producing here. So we're going to go line.index of the @ sign. But we're saying that we're going to return a string, and right now it's thinking I want it to return an integer, because that would be an integer value. But I'm going to put that inside line.substring. And if I left it like this, if I said substring, and this is at index 0, 1, 2, 3, 4, 5, 6, 7, 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8. So the @ sign is at index, what I say, 8. So if it does 8 on, I think it'll do at Apple, but I don't want the at. So let's run it and see if that happens. It should say at Apple. There's at Apple. Now if we don't want that, we can add 1 to this, and it'll skip over that index, and it'll just say Apple. Oh, but that's after Apple. We want to return everything up to the @ sign. Okay, that's a little different. So in that case, we're going to go 0 to that value. And so now it should return computer. There we go. It returns computer, because now if we go 0 to 8, it will not include index 8. Now this last one, word1.substring 2 to 6. If we go to word 1, there's index 0, 1, 2, 3, and 4. We don't have an index 6. So I have this commented because it's going to give us an error. So when we run this, now our program has an out of bounds error. You can see right here, string index out of bounds exception. And I just usually call it, we'll have several different out of bounds errors throughout the course of the class. Let's comment that. And there is the output that you should expect with these methods. Method name, character at index. An example, word.character at 3, character at given index. We have index of, and then the string, index where the start of the given string appears in this string. -1 if not found. Length, number of characters in the string. And it's word.length. You do not put it in there as an argument. Replace string 1 with string 2, a new string with all occurrences of string 1 changed to string 2. So you could replace all the A's in your word with R's. You could replace 3 letters with 3 different letters or 4 different letters or whatever you want. It could be cap, replace cap with trip. Doesn't have to be 3 for 3. Substring index 1 to index 2, remember it does not include the index 2. Or you could do substring index 1, it starts at that character and then it grabs the rest of the word, the rest of the string. You can change everything to lowercase. Notice that L is capitalized and C is capitalized. You can change all the characters to uppercase, but U is capitalized and C is capitalized. So let's practice a little bit. Index, here are all the indices right here. So string 1 is Frodo Baggins and string 2 is Gandalf the Grey. So string 1 length. String 1 length is 1, 2, 3, 4, 5, 6. The space is 6, 7, 8, 9, 10, 11, 12, 13 characters long. That's the length. What is the character at 7 for string 1? 0, 1, 2, 3, 4, 5, 6, 7. You can see the 7s right here, A. So lowercase a. Character at 0 for string 2. That is a capital G. Index of O for string 1. Index of O for string 1. That'll actually be the first one, so that'll be 2. 2 uppercase, so string 2 to uppercase. Well, that will be, let me cap lock on this, Gandalf the Grey. So it turns everything to capital letters. I'm going to space this over so it doesn't wrap down. 2 lowercase, string 2 lowercase, index of B. Oh, that's interesting. So if we do string 1, make that all lowercase, then there isn't a capital B anymore, and this will be -1, because there won't be a capital B when we say make it to lowercase temporarily. It doesn't actually change the string to lowercase. It temporarily does. So string 1 dot substring 4. So this would print, if we were to print this, the value it's going to return is index 4 to the very end for string 1. So 4 to the very end. And I can just do a copy and paste. So that's what it will print there. Substring 3 to 14 on string 2. So 3 to 14, but it will not include that 14th character. So that's what we would get right there. That's what that method would return. Replace all the A's with 2 O's in string 2. All the A's with 2 O's. All right, so more announcements. All the A's to 2 O's. Oh, I'm still on capitals. OO and OO, and that's what we wanted. That is an uppercase A, so that one will not be replaced. In string 2, replace gray with white. And so gray is capitalized. That means it will not replace anything. It won't find it. Nothing will be changed, so it'll be the exact same thing it was. Replace lowercase r with range in string 1. Oh, yeah, but look, they have quotes around this. So the answer to this is not actually this variable string 1. It's saying this string right here. So replace r with range. S-T-R-A-N-G-E, strange 1. So it actually replaced this R, literally that R, with range. Click this link and fork the problem. Now if I click this, I won't see the same dialog box as you do, but you'll have this rectangle, and in the top right-hand corner, it'll say fork, F-O-R-K. That means it's going to take a copy of that program and it's going to put into your list of programs, into your account. So click on this link, click on fork, and then you'll have your own copy. That way you don't change this one. You don't change, let's say, the master one. And go ahead, pause the video and take about, 4 or 5 minutes to see if you can fix this program, because when you run it, it will not work. It's going to have a bunch of errors, and you can fix as you go, and you can see the first error right there. So go ahead and pause it, and we'll see you in 5 minutes. Let's fix the first error that it shows, that this should be probably a variable. We're not going to say, we can't say string name. We're going to use a variable in this method. Not only that, string has to be capitalized. So we have that fixed. And if you run it, probably lots of other errors. Yep. It says next string. Well, we don't have next string. We have next, or next line, if you will. So we'll fix that. You could run it again if you'd like. Replace A with E. So that's on line 20. Well, we need name.replace. It doesn't know what variable to use if you just say replace. It also says to uppercase has an error. Same thing. We need to say name. We don't send it as a parameter. We put it as name dot to uppercase. Let's see if we can run it now. Name to, it doesn't like name to uppercase. Oh, yeah, because it's upper and we need a capital C there. Upper and case are both capitalized. Now it doesn't like length, and what we're missing there is parentheses. Type your name, Ralph, and then Ralph has 5 letters. So it did uppercase, it went index 0 to 3, and then says Ralph has 3 letters in the name. Oh, excuse me, 5 letters, not 3 letters. I was thinking 3 here. Let's go back here, select this link and fork the replicate. Write the code to produce the output. And go ahead and fork this program. And pause the video and try to produce the output and see if you run it right now. It should run. If you go Alfred Newman, it just says your name is Alfred Newman. But we want it to say last name first, comma, and then first letter of first name. Pause the video, give this one a try, and we'll see you back here in 5 or 6 minutes. Let's give this program a try. I imagine we could probably do this all in one line, but let's not do that. Let's go int space is equal to name index of the space. Because we want to know where the space is, because that's going to tell us where the last name begins. Well, now we have that in the variable space. Let's go name now is equal to name.substring space +1, so we don't start with the space. And that will grab all of the last name. It'll start with the N and go all the way to the end. Then we need a plus, a comma, plus name.substring. And we want 0 to 1. That'll grab the first letter, because it'll go from the first letter to the second letter, but it will not grab the second letter. And I don't want to end it there. We need a dot, so plus a dot. And I believe this should work. Alfred Newman. And there we have it. Your assignment is, if you go to the schedule, we have a lab and a worksheet.